Okay. Okay, so what did we do last time? Last time feels like ages ago, even though it was probably only a week. But that's what grant writing does to you. Okay. So last time we were doing some experiments with shuffle algorithms. Instead of using Zig's default one, we wanted to program our own, and likewise for a random number generator. So let's see, yeah, we did this like Fisher-Yates test where, let's see, Zig run Fisher-Yates. That's right, that's what we did. Okay. Yeah, so I did some thinking about this like the day after, and then I came up with the really somewhat like obvious statement, but it has profound effects for this algorithm, which is that if you're randomly say you're given the numbers 1 to 5 in a row, randomly selecting something uniformly from that list is the same as if the list is forwards as if the list is backwards. Like you can permute that list any way you want, and if you're choosing something uniformly, it's going to be the same. So what that means in this Fisher-Yates algorithm is that when we're like randomly picking elements to fill up the second list, it doesn't matter if we somehow like muck up the order of stuff in the first list, provided you don't do anything silly with any weird gaps. Like provided you're in some sense like reducing the size of the list you're picking things from. If you shuffle, it's going to be the same. So then I realized this means like this algorithm can massively be simplified. Or yeah, again, like we didn't spoil things by looking up on YouTube what like the good version was. We saw on Wikipedia that there was an ON version. It wasn't immediately obvious what that was, so we just implemented a crude and squared version. But this insight I had enabled me to like figure out what the ON version is. At least when I figured it out like 6 days ago. So I should probably I feel like I should write this out in words just to refresh my mind before I try implementing it in code, even though it would just be like less than 20 lines. So basically, yeah, so what's the idea? So the idea is the general sort of idea. They construct like a list by uniformly. I want to say by like uniformly randomly. By picking with uniformly random distribution items from construct list 2 by picking with uniformly random distributed items from list 1 and then sort of removing them. And then note, picking like uniformly randomly from the ordered sort of, even though this is like an obvious note, is the same as picking uniformly from, say, like 5, 4, 2, or any other permutation. Sort of as such, yeah, the algorithm, it can be like, yeah, it can be like condensed into like, condensed into a single list by like, oh yeah, by like swapping. Okay. Yeah, so the idea is, so then the idea is as following. You have your list of things. The idea is basically you're going to like, you have your like initial list, and then you want to like fill up that same list again in some ordered way. So do it from, say, like front to back, and then as you're like filling, and then you fill it up by randomly choosing something, and then swapping, like randomly choosing some position, and then randomly, and then basically like pasting that in the first position. But then you still want to be able to pick randomly from everything that's left. So you want to choose like everything after the position, kind of like minus the thing you just filled. But if you manage to swap things, you basically fill the gap. So it's basically like pick something, move it to the front, and then like paste it back in. Pick something again, move it to the second item, swap it back in. Yeah, it's a good exercise. I recommend thinking through it. So let's see. So this time we don't actually need this. We don't need the, call this like the original list. Okay, so we want to say, yeah, going from the start to the end of the list, sort of, yeah, random, like, what are we saying? Just convert the I to a U8, then so this, okay, this, we could probably still use this function we wrote last time. Once we kind of offset it. Actually, okay, in my head it was just we fill it up from like beginning to the end. It may be better if we have a procedure which randomly chooses something from 0 up to k. It would probably make more sense to fill it up from the end, going to the beginning, and then we can just like selectively kind of narrow the items which we're randomly choosing to then swap with whatever is at the end of the list. Yep. Let's annotate this. Yeah, pick a random index from yeah, from 0 to n minus I. So what we've done here. And then we then want to swap this. Swap list rn with well, it's rather with list n minus I. So let's just say the random element is equal to list rint, and then we want to say and element. I'm using really bad abbreviations. Random index. End element isn't really the right thing. It's just I want a name for the thing that I'm currently like. And then going back in. Maybe like back element. Yeah, like I'm just thinking, whatever integer, whatever type, yeah, whatever n ends up being, like in this case it would be a U64, like in general would be a U size. The byte here would just be like promoted up, so it's fine. Okay, so then we just want to say list the list n minus the I is equal to the random element, and then the list random index is equal to our back element. Okay, and then that kind of eliminates any memory copying kind of needed. And then we simply want to return the list. Yeah. Okay. Let's try giving that a go. 31. Int. Okay, oops. Out of bounds, index 5, length 5. Right. We really want to be doing n minus 1 minus I. Is this get randomish byte procedure including up to limit? No, it's strictly less than the limit. Okay. So that's still fine. And this one will likewise want this. Actually, I feel like slightly uncomfortable having like n minus 1 minus I in here when everything else is just like descriptions. I feel like for consistency, it would be good to have like back index. And just say, yeah, this back index is n minus 1 minus I. I think it just makes like what's happening easier to read. Yeah. Okay, and yeah, the same kind of problem as we observed last time. When you have really bad timing precision, you just get the same kind of things repeatedly. Okay, I'm just gonna have it down to so many of these are really similar. But in either case, this is okay. I'm kind of concerned there's no like 2s are coming up. Okay. All right. Okay, that's significantly yeah. I'm still like wondering if there's a way in Zig that if you have a for loop like this to specify like the type of the element that you're iterating over, this exists in Odin. So I would be slightly surprised if it doesn't exist in Zig. It's something I've just done so often I've got used to it. It would be good to read this, I think. You may need to dive into the compiler code to see how it's recognizing this. Specify type of range. Was this done 8 months ago? Yeah, okay. I guess a while loop is probably the nicest way to do this. It's fine. It's fine. We've massively simplified the algorithm. So again, when we translate it to the Serenum, it will be straightforward. Even more straightforward. Okay, now we want to clean up this get randomish. No. Yeah, we kind of want to clean up everything here. So here we're kind of doing like a different Xorshift each time. It would be good to like globally store some kind of yeah, I think I globally store some pseudo-random. Like we can just do our own pseudo-random number generator globally, sort of based on this, and then this way I mean a couple of things. This way we don't need to poll for timestamps every single time we do something random. That's currently what's happening. We can, and also why we're getting the exact same shuffles when we just compute all of these in a row and then print them. Again, like in the actual game, we're only calling the random thing once, but at least at this stage, when the sliding game is just a single puzzle, and after solving it, that's the end of the game. If we did want to add extra functionality, like once you solve it, like maybe you solve a 3x3 one and then you solve a 4x4 one, and we would need to call it again. Maybe we have a restart button, in which case we could do it again. I feel like conceptually it's actually easy to think about it in terms of some separate pseudo-random number generator, which is just keeping its own state, that you initialize once with the timestamp, and then we just use the Xorshift repeatedly, and then having to just do a lot of system calls. I think then in terms of like the WASM as well, eventually when we get this onto the web, clearly any kind of like system call is orders of magnitude slower than any like arithmetic thing. And again, not that like, again, this is like on the web, so it's not as if it's not as if like speed to the microsecond matters, but clearly like speed on overall, like it's unacceptable that even today we visit web pages that take like seconds to load. Like they should load within like less than 10 milliseconds. They should render within 10 milliseconds is what I should say. Yeah, it would just be nice if we read in the timestamp once at the beginning and then never have to poll for it again. Like we have to do some like extra external JavaScript code to get like the time into the WASM, and then it just stays in the WASM and everything's self-contained. So we would do that. Okay, so how do we then construct that? What's a nice data structure to contain this in? And a really easy option would just be a global chord, like PRNG state, and it just has a U64, and then whenever you want it, you just like call it and update it. We could use the Zig kind of like method syntax, kind of put this in a struct instead. So let's say we had let's call it like Xorshift. Xorshift PRNG, and it would just be like a U64, and then that's kind of it. Ooh, what's the struct syntax when we want to have a function in here? If we check out the compiler, there will be plenty of examples. Yeah, like password. Okay, maybe I need to go to something a bit more general. Maybe heap. Okay. So yeah, you just define functions as necessary, as usual within the struct. Okay. And what's the self syntax again? It's like self is Xorshift PRNG. I guess we want to that's all we need. And then we want to call self.state is equal to well, it's equal to this Xorshift. So we can say state is equal to self dot state. Copy in this. We should rename this properly. X1 is self state. Do all of that, and then okay. If we don't want to just copy in a local copy of this, we'll want to actually modify this thing. Now say self.state is equal to x4. Okay, and I think this should be our easy pseudo random number generator. So we want to initialize this. So let's just make a global that has this. Pseudo random number generator is equal to, well, we're going to have to initialize it. So we can initialize it here. So now I want to say PRNG is equal to, well, just define what it is. Maybe we can even define it like state is equal to, so this is where we want to do the timestamp stuff. So maybe it's worth writing another function that will initialize it. I've certainly seen many kind of like initializers for structs. In the standard library. Actually, I kind of want to just have it as a separate function instead of adding it inside. Initialize Xorshift PRNG. And so we want to return an Xorshift PRNG. So this is where we'll need to use all of the like timestamp kind of stuff. And I think we can just set the state to be this converted timestamp. I mean, maybe it would be good to kind of like spin the Xorshift a couple of times. Well, maybe it's fine. I feel like it should be spun at least a few times. Okay, so then let's do here, the timestamp PRNG, this Xorshift PRNG will just be Xorshift PRNG. Why do I bother tabbing? Where the state is what's the converted timestamp? And then we simply want to do Xorshift PRNG, and then we'll spin it how many times? Maybe, actually, maybe once is enough. No, let's just kind of, let's see. Let's say, we may have even done this last time. Yeah, we'll just do it 10 times. Okay. I kind of want to see this working actually. Different. Okay, so let's, we have to comment out a lot of stuff. And yeah, we simply want to do, well, we want to set this global PRNG to this initialize Xorshift PRNG. Ignore that. Okay, expected after, let's move it this way. So 108. Yeah, this is what I was a bit confused about with the syntax. 43. Undeclared identifier Xorshift 64. Well, that's because we commented it out. Yeah, it is being updated. Okay. Okay, I think we can clear out. Start clearing this up. So now we want to use this to, we want to use this PRNG in like get randomish byte. So yeah, we won't need to do any of this timestamp stuff anymore. The PRNG is way too like general of a name here. Let's call it just like global PRNG. So yeah, we'll pass in this pseudorandom number generator, and then maybe it's just as simple as like choosing the last byte of this. I feel slightly queasy about this. I guess well, I feel like it should be like better to do something from the middle because it's like getting more overlap. But I don't know how. Don't know how nonsense that claim is. So So if we're choosing the last byte, then like, we're like, nothing's happening to it in that line. Maybe, I guess something happens to it in that line, but then nothing happens to it in that line. So maybe actually just picking like the last byte is better. Or maybe the best yet is like picking the middle byte, some kind of middle byte. We might as well, yeah, pick a byte. Middle. Oh, okay, how are we going to do this in Zig? I think we just like shift it and then truncate it. So we just want to do truncate the prng.state after we shift it by how many bits. If we kind of want it in the middle, 32. Wait, why am I thinking these are bytes instead of bits? Yeah, anyway. And then once we do that, we'll want to update the state. PRNG update. Okay. Okay, so that at least clears that function up. How about the next one? Then after that, we will have cleaned up everything basically. So yeah, return a random number from 0 to limit. So we're saying the remainder is just 255 over the limit, okay. The okay range is that. Get this random byte if it's within the limit break, otherwise continue. What's the point of this line? Oh, that's right. There was some like, so this was the case where say we wanted to randomly choose between 0 and 1. We don't want to like probabilistically have to poll for random numbers constantly. So instead you want to like, you want to be able to just do stuff with modulus, but you want it to be probabilistically correct. So yeah, just like there's, you know, choosing a random number from 0 to 10 inclusive will not give you with even probability like an odd or even number, since there's one more even. Yeah, that was okay. You have to like do modular stuff. Okay, the names of this don't kind of make that clear. It would be good to think of sensible names at some stage. May as well do that now. So OK range limit is maybe like maybe like modulo limit is better. Might as well call that random byte. Oh, but we're going to have to pass in to get randomish byte here, the global PRNG. And is a bit vague. Maybe final byte. Okay. So now we should be able to get rid of this. Now we should be able to do stuff. Well, yeah, let's just print out what we had before, but now with everything new. 66. Um, 44. What? Why does the compiler not know what that is? Oh, global, not global. 67. OK range limit. Modulo limit. Oh, okay, good. Yeah, clearly our pseudorandom number generator is working, but we're like only ratcheting it up once each time in this update state, which makes me like I don't feel like that great about it. I feel like it should be called several times. Maybe we should just check out the Wikipedia page for like Xorshift and see if there's like a recommended number of times you do it. Okay, maybe maybe it is fine. Maybe fine. Again, we're not actually doing this for any cryptographic reason. We're just something about this is telling me that these shuffles are not sufficiently randomly spread in some sense. It's I find it's kind of weird that we're getting see all of these 4s and then all of these are 5s. Maybe it is okay. Okay, we'll move on. We've cleaned up the code. It's now ready to put back into our actual sliding game. So let's do add Fisher-Yates. Yeah, significantly significantly cleaned up code. Cleaned up Fisher-Yates. Okay. So yeah, we can now we should be able to just copy and paste this back into our sliding puzzle game. So let's see, we want to save all of that. And then let's just paste it all down here. We can get rid of this. Yeah, random shuffle code. That's obviously code. Random shuffle via Fisher. Am I spelling Fisher-Yates correctly? So yeah, it is just Fisher-Yates. Okay. And Xorshift. Okay, so let's find the existing random code in the tile game and then replace it. So stuff we want to replace is down here. So yeah, so we want to replace that one there. When we're initializing the PRNG here, like if we've already got this program starts timestamp, maybe we want to change the initialize here so that like we're not using that. Maybe we just have something called the init value, which is an unsigned 64-bit integer, and then we just paste it in there, and then shift it a bunch of times. But at the same time, what exactly are we using for the program start timestamp? Is this the nanoseconds? When we do stopwatch.read, what is the units again? We don't even have a comment on this. We should say. Note timestamps are in what? Zig 13. Oh, it's really current. Lib standard time.zig. It's in nanoseconds. Okay, so then we'll want to, when we do this init grid, we'll want to do the appropriate thing here. Like we'll want to truncate we'll want to do like the necessary shifts. But why am I calling this a nano timestamp if we're saying like micro timestamp? Yeah, okay. In neither case, we'll just convert the nanosecond timestamp to like a millisecond timestamp. It's fine. Or at least we'll like shave off we'll shave off the stuff that's been rounded to 100. So the seed, we don't actually want that as the seed. We want U64, but So again, if we're the need to deal with this precision shouldn't be an issue if we're only ever using this to initialize the random number generator once, which is what we are doing. So I think it's actually okay. Call this the seed. So then we want to say global PRNG. Again, this is not for cryptographic purposes, otherwise we'd be doing something very different. We just want to initialize with it, with the seed, and then now when we generate this random shuffle of these integers, now we want to say grid is this thing, and now we just apply the apply Fisher-Yates. Let's see. This grid is not even as large as a cache line, so I think it is fine if we don't like pass by a pointer, but just like read in the entire thing and then shuffle it. My guess is that would actually be faster than trying to do this like in memory. Okay, so we'll just say like grid is equal to, which is kind of how we've written this. Grid is Fisher-Yates of grid. And then okay, and then I think that's it. So let's try and compile it. Z build run. Okay. Z current build run. Expected type U6 found U64 cannot be correct. What were the second argument? Oh, okay. We were telling what the length of it was. Okay. Was it town number? Of course, it's town number. It's in the line above it. Unused function parameter init value 641. Yeah. Let's just call this seed. Okay. So generally, what does that look like? Like green's in the corner and then orange is in the third column. Okay, and yeah, it's clearly different each time. So yeah, stuff is getting shuffled. Good. Okay. Git add z incorporated Fisher-Yates Xorshift code into game. Okay, yeah, let's get this onto the cloud. Okay, so yeah, this was a good exercise. Yeah, now we can put everything we did can port over really easily to this arena. And yeah, we actually like understand. It's a fun, like, it was a fun exercise to derive this. I would recommend it as an exercise. So now what do we do in the game? So I think next up is getting image textures onto these tiles. Or we could do some fun. We could potentially play around with some vertex some fragment shaders, and actually, okay, if we're gonna do that, we'll need to replace this like background with like a rectangle to draw on. That's trivial. But then we could start, having some really like fancy background that could not at all be generated by. Because again, I'm thinking this is like going on the web. Like, they can't at all be generated by like the latest like JavaScript framework or something. Like something that could only be rendered with a GPU, and could be fun. We can play around with patterns. Let's see. Should we play around? I kind of want to. But we're gonna have to do some upgrades. Let's see. Version 1.19. We have 1.15. Let's do it later. Okay. Okay. We could very well make some fun patterns now. It's just we won't be able to get them to the game since we're not even. Actually, no. We very much can. We can. We are already calling some very basic vertex and fragment shaders, like trivial, basically. Yeah, I kind of want to play around with this. We've done the hard work of understanding the random stuff and getting stuff animated. Now I want to go to the fun. Okay. So what could we do? A way to cheat would be to browse Shader Toy and just see some cool design and then riff off that. It's always more fun making something from scratch, though. What if we just, a really simple thing we could do is like polka dots or something like that. I'm just saying polka dots since it's circles, so the code is trivial. But we could have we could just make the polka dots like animate and like slowly drifting. Or we could even like change the sizes of them, like maybe they like expand and contract. The background shouldn't be too distracting, but we could make it interesting to look at slightly. Maybe instead of polka dots, it's like something more grid-based. We could do something with noughts and crosses. Well, maybe it's like polka dots, but it's like colored polka dots that that reference these colors here. That actually might be too much. That might look nasty. Oh, okay. So what if we make something that's like, it's like polka dots most of the time, but then it like changes and like it slowly alternates between polka dots and squares. I think that like, and by slowly I mean like it takes minutes, and then a minute, and then I think this is something where people initially look at the background and go, oh, it's like static, and then it just like before they know it, it's like it's like static, and then maybe no one even notices it, but like anyone who looks, they're like, oh, okay, actually something complicated is going on behind the scenes. Like it's not just a wallpaper. Like is a custom shade is actually running. Okay, I think this could be a really fun. Like this is a very like harmless fun troll. It's like it's a fun troll. Okay, I totally want to implement this now. So, I don't know, everyone's like using version 3.3.0 these days. There's always like so many, stuff always seems so complicated. Let's just get rid of everything except time. And we are gonna have to do like the UV transformations. Let's for now we'll get it basic. So I think we can just say like gl frag coordinate is equal to, let's say we just wanted to make this wide. Wait, why can't we modify gl frag coordinate? I don't know, this color is what we want. Undeclared identifier, is it frag color? Okay. We're off to the races almost. Yeah, so let's say we have this vec2, which is just our like raw coord, which is equal to this. And then let's just make our life easy to begin with and not worry about the coordinate transformations. Like these things are standard, but I always have to look them up. We'll just do the super crude thing of like fixing them. It's divided by 1,000. Well, hang on. We'll need to normalize it, so we'll expand everything to 2,000 and then subtract it. Why is it thinking this is a 4-component vector instead of a 2? Okay. And then let's just say we have the raw coordinate here, 1, 1. Okay. not the gradient I was expecting. Okay, let's make this simple. Yeah, why is this not a gradient? Oh, right, because yeah, everything's just like 1,000. Okay. Okay, great. Okay, let's just save this in sliding. Where's like the sliding puzzle? So we'll call this like I call this like troll background. Well, or rather like disk square troll. Okay. So let's just draw a circle to begin with. So at first, I'm still confused why this wasn't normalized when we. So we'll just call normalized to this, and then the unit coords. Oh, there's just coords. Is the normalized coords -1 and what's the time from back to? Yeah. So why? Okay. Syntax. Okay. Yeah. This is better. Okay. We now do have everything going from -1 to 1 and. Just using magic numbers for the moment. Okay, so yeah, so if we want to draw a disk, let's just say let's just have a bool. That is yeah, I mean it's just equal to is the distance of the coordinate from 0 let's make a constant that's like origin. Is this thing greater than some radius? And let's just make the radius like 0.5. And then we can multiply this by the, will it convert for us? No. Unexpected equal, expected colon or semicolon. Okay, we need to give this a name. We'll call it like in disk. And if we want it to be in disk, then we want it to be less than well. Let's just start doing this properly. Oh, we can make another uniform for the radius. yeah, uniform float radius. And how do we do this in code life again? I feel like I also just want to change like, okay, so, what is it, parameters? Add parameter constant, float, and then, what do you want to call this? It has to be called the radius. And I guess we can like have it going from 0 to 1 to begin with. Okay. One times bool. Okay. Can I actually just, if I declare this as a float, will it automatically okay, I'm gonna have to do some casts. Hang on. Let's set some like background colors. Let's make it like a boring gray to begin with. Why is this not updating? Expected enter file. I got rid of this. Okay. Let's make it a bit darker. Okay, and then we want to compute what the final color should be. So we want to say we don't necessarily, we don't want to have like some kind of like, I was going to say like an if statement. Like the if statement's fine if you know what you're doing. If the compiler can turn the if statement into like something arithmetic, then it's fine. But I think we can just do the arithmetic thing to begin with. So what we want to say is we want to turn like the bool into a float to begin with. So we want this just to be like a 1 or a 0. And yeah, can I just like, this is Cast reserve word, is this? How do you cast things in GSL? I've forgotten. What? No, this can't be correct. Well, at least, really? Really? This can't be the case. I feel like I've absolutely done this before. Of course. So can we just wrap it up like this and it's fine? Oh, okay, that did it. Great. That's all we want. That's all we want to do. Okay. Where's like the reference for casting things? List of possible casts in GSL. Okay, so these casts actually are under the hood constructors apparently. Okay. Whatever. Okay. Moving on. Yeah, so we've got that. So then we can just say final color is equal to let's define like the disk color to be let's just make it some some like really boring white at the moment, and then we can just add these two together, 1 minus in disk. Well, like I think that will be splattered, so like the correct vector size. Background plus in this times disk color. Okay, and it's not showing. Okay, that sucks. Is this float working differently than what I thought it was doing? Okay, apparently everything is in the disk. Oh, because we're not using the radius. There we go. Okay. Why did I delete everything? Okay, great. Okay, finally we can we're drawing geometry in the shader. Okay, these edges are super nasty for somewhat obvious reasons. Okay, we do need to. We're using magic dimensions since we're not doing any smooth step on the boundary. I mean, it doesn't. We may as well just start making. Well, okay, the question is, do we like start? Do we start like turning this into polka dots and then do the smooth step, or do we do the smooth step and then turn it into the polka dots? I don't think it's gonna matter which order we do those in. So let's just start doing the polka dots first. Let's get many of these on the screen. Okay, so now we want some way of, okay, how are we gonna replicate these? I think we can just, if we like scale up the -1 to 1 square to something larger, and then we can drop off the part of the floats before the decimal point, and then just have everything happening in terms of like the decimal point. That will give us a repeating, that will give us a repeat. Yeah, so let's do, so the chord is this, and then yeah, let's create another uniform called like, well, we want this to be an int, called like scale, well, more like polka dot dimension. How do you even spell polka dot? Is it polka dot? Yeah. Oh no, I had no idea this existed. Oh no. How ridiculous. Web3 is the biggest scam. Polka dot. Okay, so let's do, let's actually, like, I mostly associate this with like red and white, so we may as well just get the colors kind of working. So we'll call white this thing. Can I like copy and drag it there? So let's make the background white, and then like I don't want to use like the pure red. Let's see what. Actually, maybe this will be on Wikipedia. Maybe there'll be like a suggested red color. We could use the. What's her name? Yeah, like we could use the Kusama. Or could use some of her color schemes. She's everywhere in the world. I swear, like every gallery or public park I walk into, there's like it's cool. Yeah, let's like pick the red from here. So where's this like, do we have like the power toys installed? How do you like, what's the shortcut for the color picker? Whatever, we'll just, if there's an easy way to go about this. Where's like open in paint? Okay, what's like the hex of this? Oh, God, like there's a shortcut for this that we've used. Shortcut for a hex value on screen in Windows. Yeah, I know this thing exists. What's the shortcut? Win Shift C. It's not working. Okay, that sucks. Just okay, there it is. That's all we wanted. All we wanted was that value. Okay. So let's do like x2 RGB. I swear, like, in the time we did this, I could have just written, like, a conversion in a program to do this in Zig, but oh well. Now we've got it. Well, do we? Okay, here it is. Okay. So yeah, we should call this like Kusama red. Okay, and then yeah, the disk color we want to be the Kusama red. Okay. But really, hang on, the polka dots are like sometimes the other way around, right? Like it's white on red. And what did I just do? Okay. Okay, so now we want to get lots of these around the place. So okay, but we want to let's call I want to like describe like the dimension of the grid that we'll create. So what should that? Maybe dimension is fine. Like maybe just repetitions is like a better term. Repetitions. So how do we add in another uniform simulator to this? Where's the add button? Yeah. Let's call it reps. It's easier. Okay. And then we want this to go from 0 to like 100. Actually, we'll make it go as high as, well, 100 is actually probably too much. We'll keep it at like, keep it at 100. Okay. Oh yeah, so now we need to like scale things up. So scaled is equal to, I need to cast it again, float reps times the coord. We then want to kind of truncate stuff and just look at the floor. Right, if we're kind of truncating stuff, instead of origin, let's call this like center. Let's make this center like 0.5, 0.5. And then this way we'll be able to like make repetitions of stuff. So now we want to like apply the floor floor coord. Is the floor operation like SIMD-ish? Can we actually, will it take a vector? Oh, it might. Okay. Okay, and then we want to do this with the floor coord. Maybe floor is the wrong. No, like, what's the operation called where you like it's like the opposite of floor. Like we don't want to round it down to the nearest integer. We want to get rid of function that drops the integer from float. Why am I blanking on this? What's it called? Yes, this is what I want. Just separate the float and the fraction part. No, there's a function for this. Let's bring out the LLM. I'm tired. What are the what's the GOSL function that extracts the part of a float after the decimal point? That's called fract. Okay. Aha, great. So now we've got our polka dots. We can increase the number of them. Oh, this is, yeah, this. I'm so glad we are doing this rather than fighting with OpenGL to draw textures. Okay, this is way more fun. Way more fun. Okay. Okay, so I think in order for this to actually be like polka dots, we want to have them, we don't just want them to have this cubic lattice, we also want like polka dots in the kind of centers as well. So, so I guess we have a couple of options for this. One is that we could define a different center and then do some this like in disk will just like determine if it's within the radius of like 2 of these places. That might be easier. Another thing is to do something fancy with the geometry where we're somehow like shifting them, where we modify this like fract part so that stuff gets like shifted or shifted in the like each time it. Actually, I feel like logic like. A simple way. Yeah, what would be the simplest way? Like maybe honestly, like the simplest way is just to like choose 2 points on the line of gradient 1, and like currently like we're just choosing the point in the middle of that, which is 0.5, 0.5. If we instead just like shifted it to two things, I think that would be enough. So we could just define the centers to be like a quarter, 3/4, 3/4, and then that would be fine. Okay, so let's call this like center 1 and center 2. And then, so currently, yeah, if we have like center 1 or center 2, we'll just shift between these. So we want to account for both of them. So we want to do, it's either closer to that radius or the distance is, actually I kind of want to like just break it up into, such a way that the compiler like cannot fail to turn everything into SIMD instructions. So we'll have bool in disk1. Maybe just disk1 is fine. Yeah, okay. We'll make it disk1. So disk1 is just the distance from the floor coordinate to the center 1, and then it's used to like Emacs. Disk 2 is just the same thing but with the character 1 replaced with the character 2. And then in disk here we can just say this is where we OR them and then convert it. And yet I'm getting a compilation error. Why? And what? This line. Cannot convert from global float to temp bool. Oh yeah, because we want this to be less than the radius. Okay, great. So now we have our polka dots, and it's clear from this view how exactly we're rendering them in the shader. make so many polka dots appear. Yeah, so the thing in my head that I had at the beginning was something, well, it was in black and white, but basically this. We'll smooth out these pixels so they don't look as like disgusting very soon. But like kind of slowly over time they like morph into squares. Like I don't think we should adjust like like if the shader did something like this, it would be clear to anyone playing the game that like something fishy is going on. But if we keep like the size of them the same, and especially perhaps if we like slightly animate them, and we just like turn them into a square, I think it would be a really funny, really funny draw. Okay, let's save this for the moment. And actually, let's just save this code separately as like polka dot pattern. We might want to come back to this and use it some other time. Okay. Yeah. Polka dot. Polka dots basic. GLSL. Okay. Yeah, I said git. Okay, git add Microsoft. Well, why is there lag? This mic. Come on. The Microsoft terminal is so bad. There's like lag. Oh, this is so pathetic. This is such a new logo. I mean, everyone saw that, right? Like the lag. Oh gosh. Waiting. When's the release date for Ghosty on Windows? Like, I'm like doing most development on Linux these days, and I'm just so used to like this is just so fast and without any problems. It's anyway. Git add polka dot basic. I can just literally see the lag. Let's just make it a bit easier for Windows. Git commit added basic polka dot shader. Okay. So back to here. So now there's two other things to do. The next thing is to use smooth step to make the to make it so we're not looking at literal like. So that stuff is basically anti-aliased. Or we can play around with like morphing the circle, the disk into a square. Okay, so mathematically we can interpolate between the square and the disk by using basically like the LP norms in some sense. Or maybe it'd be better to be like a diamond instead of a square. Or we could even just like alternate it between like diamonds and squares. Maybe that would be like a better draw. No. It would be more obvious this way, since the diamonds would look like that at like minute 0, and then they would look like that at minute 1. And in fact, actually, that would be the easiest thing to implement in the shader. The squares just like literally rotate, but again, like any the amount of tech required to like rotate stuff is vastly different from doing like these interpolations. We should totally do the interpolation. Okay. Okay, so instead of just using distance here, we could start doing stuff with these LP norms. Well, I need to look up a reference to this. It wouldn't hurt. Come on. Yeah, this is basically what we want. We just define this function where instead of taking squares and then a square root, you just take powers and then 1 divided by that, and then we get this. And so this way we can interpolate between the circle and the square when it's high enough. So there's this issue that if we want it to be a super crisp square, we might need to do some discontinuity thing where, I don't know, when the p is like 20 or something. Like it could be the case that when p is, okay, let's say p is 20, that it's basically indistinguishable from a square when it's like zoomed out. But kind of the easier option is actually this interpolating between like the diamond and the circle. I feel like if anything, that's actually what we should do, because then it is a bit more noticeable, and it doesn't. Then we're not bothered by like the technicality. Okay. Okay. So now we need to get shaders to do powers, which I mean, they can do exponential functions, obviously, so that's like, let's see what kind of power functions GSL has. I'll leave it like this. So hopefully like both of these are floats. Like you insert a float, there's then a power that you're taking a float of. What's gen type? What's gen type? Come on. This is why in Zig, if you have like some arbitrary type t, it's like t dot is float. You're like, okay, it's not just anything, it's like one of these. Gen type. Let's break out the LLM. What are the different types that gen type in GLSL represents? Like, I'm sure it would do floats. I'm just curious. Oh, okay, it can actually do. Really? Really? like implementing this for like a vector would be, if it's floats it's one thing, but implementing it for a vector it's like, that would be an extremely expensive instruction. Okay, at least like in the SIMD level. Okay. So it's just power, that's all it is. Okay. So let's get rid of distance. Let's get rid of both of these. Let's just say disk2 is true for the time being. Okay, so what do we, any kind of function we would define for this can be inlined anyway, so I don't see a need to like define a separate function here. But we should comment what we're doing. Yeah, apply an LP norm where P varies between 1 and 2. Okay. In which case, let's add in another parameter. This is a constant. And we'll just call it LP value. We want it to go from 1 to 2, not nan. Okay, let's keep it at 2 to begin with. LP value. Let's zoom. Oh, why can't I zoom in on CodeLife? A bit of a surprise. Make it a bit larger. Okay, so what are we doing? So we just want to raise, so it was called power, wasn't it? Yeah. Power of, it should be x to the power of, yeah, like this should just be like the first thing. Results are undefined if x is negative or x is 0 and y is 0. Well, calculus would tell you what that should be, but oh well. I don't have to like type out floor chord repeatedly. Okay, so we have chord x, and then we want to raise it to this p. And we want to add to that the y coordinate raised to the LP value. And then we want to now take the reciprocal of this. So that is, we want to do 1 divided by LP value. And now we want to compare that to the radius. Okay, wasn't expecting that. Let's back this up a bit. Yeah, y is I was just typing the formula in my head, but not thinking. We haven't thought through what this is doing. Being super silly. We want to take like the pairwise difference of all of these things. Okay, so let's do vec2, which is called like difference 1, which is the coord minus the first center. Vec2, which is diff2, which is the coordinate minus the center 2. And now like we've actually got the vector between them, and now that's the thing we want to plug into this. So now we want to say, what is it? Yeah, power of diff1 dot x to the LP value. I now just want to change it to LP. Plus the power of diff2 dot y LP. 1.0 divided by LP. Now we want to make that less than the radius. Oh no, and it's still just. Oh well, it's completely right because we made that true instead of false. Okay, now I'm not getting anything at all. Like really? Really? Okay. Okay. This is better. Okay. Aha. So we can wait. We've almost got it. We can see here that that's like the diamond, which is what we want. And then it's becoming a circle, which is what we want. So we've nearly finished this troll. Well, we also need to do smooth step, but we've nearly got like the core mathematics down. It's just a matter now of making this behave and not just totally cut off everything. Okay, so well, I mean that's because we haven't actually done the LP norm. We need to divide by 1 over LP. So that makes it sharper. Okay, why is this like cutoff happening? Oh, because we're doing diff1 and diff2. That's really silly. Okay. Slightly better, but again, we're not. Yeah, like where are these horizontal bars coming? Where are these like grids coming from? Like what am I not understanding? Oh, is it because I think it's because when we're doing this difference, some of these values are going to be negative, and as the function reminds us, it's undefined if it's less than 0. So so we just want to take the absolute value of it then. But that again, is it? Hopefully the absolute value should. Okay. Yeah, the absolute value should have a have this kind of SIMD. Okay, great. Excellent. Okay, so yeah, so this is the troll. Okay, now we have the troll almost working, or basically working. Maybe like when you load the game, it's like that, and then after a minute, it's like turned into that, and we transform it so slowly that no one notices. And yet you can notice the pixels are changing now because again we haven't smoothed it out, but we basically, this is satisfying. It's quite satisfying. Okay. Okay. Great. So that's we just copy this, but replace the character 1 with 2. And yeah, so we have polka dots here, or the squares. And maybe we can even increase the size a bit. Okay. So now we want to now we want to deal with the smooth step. So let's bring the reps from and yeah, clearly like so I'm imagining it's something like this. The background's like this. And then over time the background becomes that. Anyway, let's bring the refs way back down to 0, like I'll do 1, type in 1. Okay, so now yeah, we have to do smooth stuff. We've been delaying it for so long. Let's anti-alias these edges. So what's the GSL syntax again for smooth step? Okay. Smooth step. Smooth step. Yes, we know what smooth step is. We just want to know where the arguments are. Okay. Okay, so it's value. Yeah, it's lower value, higher value argument. Yeah, lower, upper. Like, why are these named edge 0 and edge 1? Wouldn't it be better to just call it like lower edge and upper edge, and then people wouldn't even need to read this? They could just go, oh, right, it's lower, it's upper, that's how it works. Anyway. Okay, so we want to do, okay, so now we have a way of having a value, moving it up. So we're going to have to modify, well, okay, we can now change like the Boolean to, we can get rid of this radius and instead like plug in like the bounds of the radius where we want to smooth stuff out. So we should define like this radius to maybe be like the inner radius. We'll keep it with radius, but then we'll have like the kind of like radius border, which is where we'll actually apply like the smooth step onto it. So we can make this just a constant, like radius. We should just describe what it is. Smooth step width. Wow, in which case it's going to be constant. Stop. Smooth step. Smooth step width. Okay. So then, yeah, we want to turn all of this into a value from 0 to 1 instead of a Boolean. So, and then I guess we're going to be adding the two together. So we can say this one's now a float. So then we now want this to be smooth step, and we have to do edge 0 and edge 1, and remember edge 0 is the lower. So this is now, this is just the radius. And then we want to have the radius plus the smooth step width. Then the value. Oh, hang on. Is this smooth step assuming it's between, always going to output 0 and 1, or is it going to output 0 and okay, it already has been normalized. Okay. Okay. Calling this disk 1 now is a bit vague-ish. So why don't we, I feel like inside, we'll keep it at disk 1. Like it's short enough that, like 1, we're writing this, and short enough 2 that if we read this again in the future, we can probably figure out what's going on. But like wrapping, I feel like we're packing too much into a single line now. Yeah, let's expand this out a bit. So my disk 1 LP is not good. Not a good name. Disk 1 radius isn't that great either. Maybe like dot 1 radius. Maybe just LP value dot 1. maybe it's .1 LP. Okay, yeah, .1 LP makes sense. So yeah, .1 LP is this. And then likewise, okay, let's get rid of this part. .2 LP is that. Okay, and now, oops, I shouldn't have saved that. We'll get it up and running shortly. We now want to put these values into the smooth step. So we've got, yeah, the radius, smooth step radius, and now .1 LP. So this will just give us a value between 0 and 1. Likewise, we want to do this for, I'm calling this disk, but it should really be called like .1 and .2. Or rather, what's the mathematical name for the chord again? Is there a name for this shape? Oh, I guess it's a unit circle. It technically is a unit circle, but that may be confusing. Okay, and now we want to just add these up. .1 plus .2. And okay, this thing must be initialized. Sure, let's make this smooth step width huge to begin with. Okay, that is too huge. Okay, what are we doing wrong? Why is everything wide? Because we actually want to do this. Haha, okay. Now everything's super blurry, but it's still working. Let's massively reduce this smooth step width. Okay, great. Now it's almost like too anti-aliased now. What about this now? Is this better? What if we go to 5? Like it is a bit zoomed in on this screen. 3 looks good to me. Yeah, this looks like crisp enough. If we go to 2, I can still see borders. Okay. Okay, so now great. Okay, so now we have basically finished our troll. Well, almost. We need to sync up the time now so that it automatically moves back and forth. But let's increase the reps. See, yeah, and like, okay, now it's like we're gonna have to change the smooth step again. Yeah. Is 9 too much? Oh, what are we? Hang on, we're still is there a better way to deal with this? do with this drop off than what we have down here. Maybe it is fine. Yeah, this is gonna be a really good troll. Okay, so maybe it would be. I feel like it would. I feel like we should. We should just like based on this picture up here. Ultimately, this is what it's gonna look like. The grid will be in front of this. The sliding puzzle game will be in front of this. We want to minimize. We want to get like the size correct, basically. So these to me look too large. I want to make them smaller. So let's, and there's also too few of them. I think something like this is a bit better. However, they seem a bit too large. This is such a subtle troll that's going on. Okay, so we want to make them slightly smaller, like not, how small do we go? So yeah, it still needs to be. Like the spread, like I'm comfortable now with the spread of these. Looking at them here, they're still a bit too large. Yeah, I think I like something like this more. Like I think this is subtle enough that yeah, you can still tell that these are diamonds, and then that happens, and it's like, oh, but they're not diamonds anymore. So we can. Yeah, maybe here. Okay. And then okay, more anti-aliasing. Okay, so yeah, clearly not that blurry. One doesn't look good. 2 is a bit too blurry. Maybe we go midway. 1.5. Yeah, this will be good. This will be good. Okay. Save that. Okay, let's likewise. We're so close to finishing this. Let's link up. How long have we been streaming for? Nearly 2.5 hours. Yeah, let's go to 3. Let's finish this. Let's finish the job. And then maybe next stream we can actually get it rendering in the in the app. This also looks really like end of year, New Year's, Christmassy. Might do something like this as an exercise across the holiday season next year. Yeah, next time we'll actually get into yeah, the aim, we'll get this, we'll get the fragment shader working. Next time we'll get it into the game. So, so we just want to like automatically start varying the float now. So this uniform time is determined by is fed in by code life. So let's, I want to save this. I want to save this now in case it crashes or something. polka.troll.gls. Okay. Git add polka troll. Added nearly complete troll version of polka dots. Okay. What happened? Okay. So yeah, so let's get rid of, we won't entirely get rid of it, but we have to deal with the time. So we want to put the time into a sine function and have the output of that sine function, I should say just a trig function. Or even more generally, just some kind of like repetitious function. And then a periodic function, that's what I was looking for. Put the time into a periodic function, put the output into the LP value. We need to change that. So yeah, do that with the chords. Yeah, calculate LP value based on the time. So let's call the current LP value here LP old. And here we'll say like float LP equals LP old. So we're going to replace this soon, or we can replace it now. So LP, we want this to range between 0 and 1. LP ranges between 1 and 2. So yeah, so we want to say LP is, we could immediately write out what the function is in terms of the time now, but I think I would want to break it up again. So we could say float periodic value is equal to the sine of the time. We're going to have to get the speed correct though. This is, and again, this is yet another case where who knows why GSLW, GLSL doesn't have like a pi constant. It's so wild. You just have to just like, add it in yourself. So dumb. So dumb. Okay, so yeah, if we want to like, let's see, we're going to have to divide, since the sine function has a period of 2 pi, if we want to normalize it, we want to divide it by pi, divided by 2 pi. In here we should add in the let's think. It would be good to have a constant that describes the speed. So let's have, I guess this should be in timing. Shape change period. So let's make this like 1 second to begin with. Then, yeah, this time is in seconds. Then we want to divide this by, what is it just called? Shape change period. And then I mean, right, like let's say we're changing it every like 5 seconds, then we want the value inside of this to range between 0 and pi every 5 seconds. So then this will oh, hang on, I'm being silly. I think we actually want time divided by the shape change period. This is now going to like be between 0 and 1, and then we actually want to multiply that by pi. Okay. Okay, so that's going to give us some value between -1 and 1. We want to convert that to between 1 and 2. So we just say LP is equal to, let's scale the periodic value down by half, and then so now it's between, the range of it is now between 1 and 2. And then we just add 0.5 to it. Hang on, we add 1.5 to it. Okay. And then got a compile error on 7. Aha, great. We can see if we massively increase the if we decrease the reps from 7 to 1, it's doing its thing in the background really quickly, but approximately changing every second. Okay, so move this back to 7. So the reps should be around 7. We can now get rid of, well, we don't need LP old. What are some other constants in here that some values here we're relying on? That's the radius. So we want this to be around 0.08. Okay. So now we need to adjust the time, but we should be able to. We can set this just before we like ship it. Let's save. Let's update the Polka.tro. Okay. This was fun. It's been so long. Like clearly, it's been so long since I've had fun with doing some graphics programming. So this was good. This is really good. This was very fun. Gamedev. Yeah, we didn't really change that much about it. Add Polka.tro. Yeah, basically, finished. The Polka.shader. How is main different? Not really that different at all. There's no need to remember this KL project, so we'll add that to the git ignore. KL proj. And then yeah, as for main, I guess I can put at the top here, like to do draw the use the Polka.shader to draw the background. Okay. Like I kind of know what this is, but old habits die hard. Yeah. Added a reminder for next time. Okay, so yeah, thanks everyone who stopped by. And yeah, I'm gonna have something to eat now. It feels so good to be done with like the first grant this month. My goodness, it was the programming like stopped, so I had to just fill out. Okay, luckily I didn't actually have to fill out a bunch of ridiculous Microsoft Word templates for the latest bunch of grants. Like incredibly, they were open format, so I was just able to do them in LaTeX. I was like, finally, I can fill out a grant using Emacs. I cannot remember the last time I've done this. But it still wasn't, LaTeX is not programming, obviously. Yeah, it wasn't, anyway, yeah, I hope everyone has a good time wherever you are in the world, and maybe I'll see you next time. Bye.